So good evening everybody. Today we will basically going to solve a mathematical question regarding integral calculus, and the question that we need to solve is that we need to integrate this expression. This is a complete trigonometric integrand and we need to evaluate its answer on a general sense, because it is an indefinite integral as it is not having any uppercase or lowercase limits. So let us try to figure it out. Since we can see that we are basically having sin x and cos x terms in this question, we can try to make this expression as sec and tan. Okay, because we all know that the derivative of sec is tan, and then we can completely reduce this integral question with respect to a tan function. That we can do simply. So first we need to factorize it nicely so that we can make it in a way of sec x and tan x. So sin square x and cos square x are multiplied in the numerator, and in the denominator you are having a bigger trigonometric expression having degree of 5. So the denominator is homogeneous in the form because each and every term of it is having a fifth degree, as we can all see here. So this is the expression that it is being given to us, and we need to solve this. Okay, in order to make the numerator completely of sec x, then we do not need any sin x. And in order to remove all the sin x which are there in this question, we at least need one sin x extracted from the denominator in order to make it as sin square x. That will going to cancel this sin square x and make the expression completely of cos, that we can later on convert into sec, and then we can through its derivative we're going to make it into a tan, and then in a way this question can be converted into a tan function or a tan integrand. So we will not going to interfere anything with the numerator. We need to modify our denominator in a way that the sin square x part of the numerator get cancelled, and the above numerator can be modified to a sec function in order to make it as a tan derivative function that can be integrated very easily, because generally it is always quadratic. So we need to extract one sin x and cos square x. That we need to do here. So what we can do is we can take sin square x here as common. Then we can make this as a sine of cube x, or we can simply take I guess cos 5x as common. Yeah, we can simply take cos 5x as common in this case. We need to make it in a form of tan and cos. So if we take cos of 5x as common inside the denominator, then this will basically going to be tan of 5x divided by cos of 5x will basically going to make it as tan square x. This thing will basically going to become tan cube x, and this one will going to become 1 obviously. So this will going to be the function in that case. So integrating it, we will basically going to have sin square x into cos square x dx divided by cos of 10x multiplied with tan square x. If we take common, it will going to become 1 plus tan cube x plus 1 plus tan cube x whole square. So we will basically going to have sine square x into cos square x divided by cos to the power of 10x, and 1 plus tan cube x here in the denominator, multiplied with 1 plus tan square x being factorized. And we all know that sec square x minus tan square x is equals to 1, which means that sec square x is equals to 1 plus tan square x. So it can simply become sec square x whole square. So continuing with our integration, so we are having our cube sine square x term, which we need to eliminate in any way that is possible for us to be. Then cos 10x multiplied with sec 4x, which will going to become 1 divided by cos of 4x into 1 plus tan cube x whole square dx. Now the whole cancellation thing will going to start off. This will going to become sine square x, and this cos will basically going to become cos 6x, क्योंकि ये डिनोमिनेटर में डिवाइड हो रहा है तो न्यूमरेटर में जाके मल्टीप्लाई हो जाएगा। भाई इतनी सिंपल सी मल्टीप्लिकेशन तो तुम लोगों को आती होगी मेरे हिसाब से। तो ये तुम्हारा ये हो जाएगा, फिर तुम्हारा cos 10x जो नीचे है मल्टीप्लाइड विद 1 प्लस tan cube x to the whole square. Now we need to like change it in a way so that it can become good function. Now we need to distribute this cos 10x in the numerator in order to make this function as a tan function. So what we can do is we are basically having a sine square x, we are having a cos 6x, and we are having 1 dx. Okay. And we are having in our denominator as 1 plus tan cube x whole square. So we can make our cos 10x as cos square x into cos 6x into cos square x, so that this cos square x in the denominator will become the sec square x in the numerator, and then we can basically going to get a tan derivative. So this will basically going to cancel because this is also cos 6x in the numerator and this is cos 6x in the denominator. Now we will going to remain with sine square x divided by cos square x, that will going to become tan square x, and we are having a sec square x multiplied with dx divided by 1 plus tan cube x to the whole square. Okay. Then we will basically going to have tan square x into d of tan x divided by 1 plus tan cube x whole square. So this is the thing. If we divide the integration by 1 by 3, then in the numerator we can multiply 1 3, because the thing is the same, we are dividing 3, so we are multiplying 3 in the numerator on a whole, the whole thing neutralizes, so it can become 3 tan square x multiplied with d of tan x, okay, divided by 1 plus tan cube x whole square. So we all know that d of tan cube x is equals to 3 times of tan square x. So we can write the numerator in this case as d of tan cube x also, and since 1 is a constant, so we can also add 1 because nothing will going to happen, because the derivative of 1 will going to be 0. So tan cube x whole square. So this is a very simple expression, it can simply be integrated, so the answer will going to be 1 by 3 into 1 plus tan cube x minus 2 plus 1 divided by minus 2 plus 1, so the answer will basically going to become 1 by 3 times of 1 plus tan cube x plus 3 will basically going to be our answer, and that is the video. Thank you.